in Rastriall. Bem-vindo nossa família do Brasil. We're just very grateful that everyone's here from all over the globe. And to start, we want to give a little introduction about who iMediSync is. On this call today, we have Cody Newman. He's our Director of Customer Relations and our IT. Chris Che, Director of Operations. Carlos Chinchilla, Director of Business Development, and myself, Rebecca Walker, Director of Marketing. Not to be confused with our presenter, Becky Bassham. It happens a lot. And we also want to give some recognition to our CEO and founder, Dr. Kong, our Head of Research and Development, Dr. Kim, and ours truly, Dave Burkus, CFO for iMediSync Americas. To explain a little bit about who we are is we use AI-driven analysis for mental health platform. We utilize EEG measurement technology integrated with EEG, HRV analysis, and AI biomarkers. And this is to offer preventative monitoring and evidence-based care. So we have here is a picture of our device called the iSync Wave. It's a 19-channel dry electrode headset. And that's what we use to collect the EEG. Then we have our database below called iSync Brain. It's age and sex matched database that uses AI denoising and generates comprehensive reports for the clinician and easy to understand reports for the client as well. So even though this webinar today is specifically on brain health in sports and sports medicine, we cover many topics and many areas that we can be implemented, such as pediatrics, neurology, epileptology, Alzheimer's, dementia, research, and PBM, which is photobiomodulation therapy. I also want to mention that coming up in March, we have another webinar, which is HRV and EEG with our friend Santiago Brand. And if you're ever interested in any future events, you can look at our website, iMediSyncAmericas.com, to see what events and webinars we have posted. We're a very friendly group, so please follow us on Facebook, Instagram, LinkedIn. We'd love to hear a little bit more about you, get to know you better. You can schedule a demo and visit our website as well. So without further ado, we'd love to welcome Becky Bassham. She is certified BCN, qEEGT, and ARRT. She has assisted numerous NFL players on their rehabilitation journey, and I personally enjoyed listening to her insights as she's experienced firsthand this path of people improving their brain health and having better results. And Rebecca, I know you're going to give a little bit of an intro on yourself, so I'll turn the time over for you to present.
Okay. I'm going to hit screen share, entire screen, share. Okay, can you see my screen now?
It's loading.
Loading, and yes, we can.
Okay, so Rebecca Walker will be moderating. I'm going to be sharing my slides. I will not be able to see your lovely faces. If you have any questions, feel free to, well, you won't be able to speak up, you're muted, but you can ask in the chat. Rebecca will be moderating, and feel free to ask questions. Okay, there's never any dumb question. So without further ado, here we go. Welcome to my world. It's a busy place. I'm going to share once again. Here are my slides. Okay, well, I want to thank you all for joining us here today. And my goal here is just to give you some insights on how I have been using quantitative EEG, brain mapping, and photobiomodulation in my practice. So just a little background. I've been in the field of neurofeedback and qEEG for 14 years. In 2016, I took on this project starting a neuroscience department in a recovery center, so inpatient recovery center for addictions and TBI recovery in Oxnard, California. Spent 6 years there starting their neuroscience department, basically with a pile of equipment and a couple empty rooms, and jumped into the trenches. Most of our population, especially the last 4 years, was exclusively recently retired NFL players. Okay. So, and then in the fall of 2021, one of my techs and I started with the help of Sue Wilson. We started a neuro performance lab at the NFL Hall of Fame Stadium. It was their alum academy. Basically, it was analogous to a bullpen for NFL linemen. These were guys that had just recently been cut from their teams. And so they had their careers pulled the rug out from under them. And none of them, well, all but one of them, had 22 guys for 2 months. Some of them came in and out. They weren't all there the whole 2 months, but basically only one of them was sleeping well at night. They were terribly traumatized. They needed to focus and get their game back on again. And it was our job to work on their peak performance. So I was there for a couple months, and brain mapped them all. And now I'm currently a free agent. I spend my time mentoring. I have a qEEG report writing service, consulting, concierge, travel, free agent work, and also working with a group of people in Malibu at a concierge medical practice. It's an alternative wellness center. So let's just start out. I'm not sure, I think we have a variety of people from different backgrounds. So I'm just going to give a brief overview on what is qEEG. And once again, I'm going to be describing how we use quantitative EEG to target treatment for these people and what some of the applications are. So what is quantitative EEG? For those of you who are not familiar with it, it's also known as brain mapping, whereby we record the brain waves, basically the electrical activity at the surface of the head on the scalp using 19 active electrodes. Most of the electrical activity at the scalp is indicative of what's happening underneath or the surface or cortex of the brain. And what we're doing is we're imaging the electrical activity of the brain. So my credentials include neurofeedback and quantitative EEG, and that ARRT stands for American Registry of Radiologic Technologists, that means basically I'm a medical imaging specialist specialized in CT and MRI. So I found this imaging of electrical activity of the brain very, very fascinating. It gave us so much more information. What it does is it quantifies the power and the frequency distribution of brain waves, which are associated with different states of consciousness and arousal level. We map out areas of functions to connect the dots between function and underlying neurophysiology. It gives us really high spatial resolution. Basically, in S-Loretta especially, it gives us up to 5 millimeter spatial resolution, which equates to about the standard CT resolution. And it gives us superb temporal resolution. We can watch brainwaves down and watch them down to the millisecond. So this hands down gives us far better temporal resolution than some of your radiology imaging. It's all good, but what we are able to do here with qEEG is identify states and traits of the brain. Now I'm going to get into that a little bit more. So basically, you've got all these different areas in your brain that are in charge of different functions. This is a general overview whereby we have the frontal lobes in yellow. Frontal lobes are in charge of thinking, planning, motor execution, executive function, and control of moods. It's basically focus and attention central. We've got the temporal lobes, which is language, auditory processing, involved in memory and emotions. The anterior cingulate gyrus, that's focus and attention central. Basically, it's like the conductor of the symphony. It's in charge of what your brain's paying attention to at any given moment. The parietal lobes are your sense of time and space. Occipital lobes, visual processing. Posterior cingulate is attention, long-term memory. It's also where your in your head voice lives, whereas your frontal lobes are your external focus of attention. Your posterior cingulus, your precuneus back here, and your deep limbic lobes in the back of your head that's where your internal focus of attention is. Push pause on that. Don't forget, because we're going to come back to it. We're going to see how this really affects the way you think and pay attention. And then we've got our friend, the parahippocampal gyrus, which is where memory, short-term memory lies. So once again, with quantitative EEG, we're mapping out the function in different areas, the electrical activity in different areas of the brain. And not just how much electrical activity, but breaking it down. This is where we get the word quantitative EEG, as opposed to diagnostic EEG at your neurologist's office. We're not just looking at squiggly lines here, but we are able to actually map out the distribution of the different speeds of brain waves. Each one of the electrodes is going to measure an area about the size of a silver dollar. I don't know if you can see me in these gestures I'm making. I can't see myself, but so each one of the electrodes measures an area about the size of a silver dollar, and there are over 100 billion neurons in the brain and more connections than stars in the universe. So there's a lot of activity going on underneath each one of those electrodes. So what this software allows us to do is break it down by speed. All of these different brain waves are present at any given time to a certain degree. We're looking at dominant frequencies and basically the dominant state frequency of the power and the distribution. So when you figure out how much power and how fast and what's the average speed of the power in each of these different areas of the brain, it gives us a lot of information about how a brain works. Now, I always tell people, cannot read their minds. This is not voodoo hocus pocus, but we can get a lot of information about how a brain works. So what are we doing with this information? Well, I'm focusing on sport right now. And one of the things we can do just from the get-go is we can record a preseason baseline EEG. Basically, what does that person's brain look like at the beginning of the season? And then we have something to compare to if they have a head injury, or maybe they get in a car accident, or something happens. If something happens, maybe they're having some sort of an issue, we can repeat their EEG and compare it to the preseason baseline. So we have a point of reference. And we also use qEEG and comprehensive concussion management. So basically, a guy gets hit in the head. It happens in football, right? It happens every day. But that's what we have helmets for. So we can manage concussions. And what I mean is, well, how do we know a guy's ready to return to play? Sure, they have those tests and things like that, but how do we really know? How would you know if you don't look? And I'm gonna be sharing with you some of the things that we look for. And we can also use it for peak performance. And that's what I was doing at the NFL Academy. Once I got people sleeping and breathing and able to pay attention a little bit better and be present, we can actually look at brainwave patterns that are associated with peak performance. Ever heard of that term, the flow state or the zone? There's actually brainwave frequencies associated with that, and we can train them. So we can use the quantitative EEG to figure out where a guy is or where any athlete is, and help them achieve the state that they need to be. But once again, how would we know if we don't look at where they are now? And then, of course, after intervention, look at where they are. So basically for progress tracking. So understanding TBI, if you're not familiar with it, TBI, traumatic brain injury. And we've got Dr. Bruno on board here in case anybody has any questions that are above my pay grade or bandwidth, but he's here. Thank you very much for joining us. So understanding TBI. Okay, so here's, and I don't want to pick on football only, and I'm not picking on them. I'm really, really here to support the football league, from Pop Warner and Pee Wee all the way up through professional athletes. And I haven't just worked with football players, but soccer players. Soccer is a big deal. Soccer players are heading the ball, no helmet, and furthermore, females don't have, their skulls are not as thick, and they don't have as thick of musculature in their neck and shoulders, and so they're even more susceptible to head injuries. So I am going to click here on this link. Let's just take a brief look. There we go. Okay, I'm losing my cursor. There we go. Okay, everybody, some of you might want to cover your eyes. Ouch.
Here comes the, here comes the, here comes the.
Okay, I think we've seen enough, folks. So, do you think those guys, I mean, when they take hits like that, other parts of the body, we see it. They're on the sidelines, they get help. We see the guy maybe has a broken bone or a sprained ankle. But when it's the head, when it's the brain, we don't see it on the outside. But on the inside, the brain is essentially bruised, okay? TBI has been one of the leading causes of morbidity, disability, and mortality across all ages. Globally, more than 50 million individuals suffer from TBIs each year. And folks, it doesn't have to be a major loss of consciousness, something that shows up on the CT or MRI. It could even be a mild traumatic brain injury, but it can result in compromised function. As of 2005, approximately 3.17 million TBI survivors experienced post-traumatic complications, ranging from neurological, psychosocial problems to long-term disabilities. The immense expenditure on clinical management of TBI patients and associated socioeconomic problems have imposed a heavy burden on the healthcare system and the society, not just in general, but even down to the workforce and the family unit. Increasing an understanding of the clinical characteristics and the underlying complex pathophysiological methods of TBI has led to the development of novel and promising therapeutic approaches that show promising effects in preclinical studies in phase 1 and 2 trials. And this is what we're going to be sharing with you today. So, and it's not just where your head hits the forced object, hits the object, but the other side. The brain is floating around in the skull within cerebrospinal fluid, and it's just floating freely. So when you hit, for instance, the front of your head, the brain bounces to the back of the skull and goes back and forth. And furthermore, not just the front and back, but it goes back and forth within the petrous ridges of the temporal bone. And so you end up, I will see this time and time again, I will see, you can see my cursor here, injuries of the temporal lobes, even with front to back injuries, even whiplash injuries. The temporal lobes bounce back and forth once again against the bony structures within the ventral surface of the skull. This is just a brief overview. I want to make sure we have time I want to run you through the software and really how we're using it to image the electrical activity of the brain, which has everything to do with how a brain functions. So pathophysiology of TBI, once again, we have Dr. Bruno on board here if people have questions, but basically it's the TBI falls into two categories. The primary injury, which is an injury which is directly caused by the mechanical forces itself. This results in DAI, diffuse axonal injury. Basically, you have a shearing of the axons and the dendrites, so the electrical signal does not get through. Contusions, just like you see on the outside of the body, they happen within the brain themselves, and this causes compromised blood supply. Could be hematomas, hemorrhaging, and could even be an ischemia, a vascular or traumatic ischemia. You've got swelling that's going to create increased pressure on the blood vessels themselves, from the large ones even down to the capillaries. And when you have that narrowing, just like narrowing of the arteries for circulation, if you have a narrowing or some pressure on the vasculature of the brain, it's going to result in decreased blood flow and hence decreased electrical activity. And I'm going to show you what we see on the EEG. Then there's the secondary injury. This happens over a period of time, further tissue and cellular damages following the primary insult. And this can last from hours to even years, folks. And we see a lot of these symptoms not right away. It maxes, it begins to surface about 3 to 6 months after the injury. They said, you know, when the outside, the thing with brain injuries is that once all the bruises and the bumps, even the stitches, everything, once that heals on the outside, it does not reflect what's happening on the inside. It's just like this silent injury that goes unnoticed. On the outside, everything looks like it's healed, but on the inside, it's not good. It results in some of the long-term effects: excitotoxicity, mitochondrial dysfunction, oxidative stress, lipid peroxidation, neuroinflammation, axon degeneration, and apoptotic cell death. And here's just a image of what some of this stuff looks like, and some of the common pathways in neurodegenerative and psychiatric disease. Once again, you've got the issues at the cellular level, and now you've got things more within the larger scheme of the things as far as the brain lobes themselves, some of the implications. And then it results in psychological issues, memory issues. Down the line, memory can predispose you to Parkinson's, depression. We're going to talk about that more. Post-traumatic stress disorder, bipolar, mood issues, memory issues, insomnia is another. There's this whole cascade of post-concussive symptoms that happen, some of them right away, and then some of them over time. We would see anxiety, depression, PTSD, insomnia, polysubstance abuse as people who were self-medicating, mood issues, explosive behavior, impulsivity, hyperexcitability, overarousal, and explosive overreactivity, basically the volatile, a lot of volatile issues. And I saw that a lot with the female soccer players. So that said, we map out the brains to identify what's happening. And how would you know if you don't look? And there are several different neuromarkers of even some of the same symptoms. So we take a look at it, and then we're using photobiomodulation, or near infrared photobiomodulation, basically red light therapy, to target areas. We map out where we see these focal anomalies, and then we are able to target treatment to help these guys, or people in general. I don't want to just say guys, but okay, we can help whoever comes into us for help. So enter the iSync Wave helmet. It will, like Rebecca told us in the intro, it allows us to record brain waves, map them out in quantitative EEG brain maps so that we can actually see what's happening in that person's brain, and also delivers near-infrared photobiomodulation. And we determine, once again, what sites and what frequency or cycles per second of the pulsing of the light based on what we see on the brain map of the individual. It's not one size fits all or cookie cutter approach. And that's what's so special about this helmet, is it allows us to choose any or all of the 19 sites and pick which ones and what frequency to target based on what we see on the map. It's not just a standard put the cap on the head and hit the button and tell the brain to do some cookie cutter, once again, in the box protocol. The iSync Wave helmet allows us to custom target treatment for that person's brain. It's non-invasive, it's painless, it's portable, and it's also affordable. And I want you, we're comparing here the qEEG brain map imaging to somebody going, for instance, for a CT or MRI. Once again, this is portable. This is something somebody can do in their home. They would most likely initially come into such as myself, or some of you folks who are attending here, like Sherry, and where they would go into somebody's office, have some clinical guidance, and then they can be sent home with one of these caps to be working under supervision and getting their treatment at home. So photobiomodulation was started in 1967 by Andre Mester in Hungary. It's once again painless, non-invasive therapy whereby we're applying 1 to 10 watts of 800 to 1100 nanometer wavelength near-infrared light with photodiodes placed on the scalp. So in the case of the iSync Wave helmet, we're applying 850 nanometers in the helmet. Okay, once again, 19 diodes. It affects tissues at the cellular level, and it's the mechanism it's most associated with is the endpoint in the respiratory chain, in the mitochondria of the organ, of the nucleus of the neurons themselves. It affects cellular metabolism. Okay, it can dissociate nitrous oxide in damaged or hypoxic cells. Once again, in the case of TBI, not just TBI, but like Rebecca mentioned earlier, we can use it to help stroke or other issues in the brain. But once again, the focus here is on traumatic brain injury. And it has a positive effect, once again, on the membrane potential, increases oxygen consumption, glucose metabolism, ATP production in the mitochondria. And the researchers and clinicians have used photobiomodulation to actually regenerate cells and heal. That's a really good thing for the brain. You know, years ago, it was thought that once a neuron or a brain cell was damaged, it was damaged for life and it couldn't heal. But that is not the case, folks. And we are seeing amazing results. So once again, can heal damage as a result of ischemia or narrowing of blood flow, stroke, injuries, or even degenerative disease. Has an antioxidant effect, cytoprotective, and once again, affects the metabolism in the mitochondria. Has a beneficial influence on ion channels. Sorry, this slide is so busy here, but I did not want to leave anything out. And also influences metabolism at the calcium ion channel, which results in increased availability and consumption of oxygen. These effects have been known to last up to months at a time, and can be administered 1 to 3 times per day, could be every day, could be 2 times per week, once a day. So basically we can do this anytime, and especially, once again, with the affordability and the portability and the flexibility of the iSync Wave helmet, we can really reach out and help a multitude of people. So here's a visual for those of you who are more visually inclined. This is, and I'm not going to take a bunch of time to go through this. Maybe Dr. Bruno may want to comment, but basically this is what we're looking at. The light it actually shines through the hair, the scalp, the skull, and can penetrate up to about 3 centimeters through all of this tissue and influence the brain. And the penetration is actually even deeper than that of transcranial magnetic stimulation. And once again, we can influence more than one site and program multiple. We can program a variety of frequencies, not all at the same time, but you can do a succession of pulsing frequencies. I'm going to come back to that. So once again, here's an image of what's happening at the cellular and metabolic level. And now let's get into our case study. I want to make sure I saved the second portion of this webinar to actually dive in and look at a case. So this one that we're looking at is a recently retired football player, and who came into our facility having a lot of trouble. So recorded his brain waves, mapped it all out, and what we're looking at here, I'm going to move my Sharon, you probably can't see that. Okay, so what we're looking at when we record EEG, we record it in two conditions. Once, typically we're looking at about 10-minute recording, each of those recordings for a total of 20. We're going to record data with the eyes closed and then also with eyes open. Ideally, your brain should be a totally different place between eyes open and eyes closed. One is just eyes closed, the other eyes open. A lot more stuff going on. Potentially, ideally, in a perfect world with a brain that's functioning optimally, you want it to look different, but we don't always see it that way. I've seen brains where sometimes when eyes are closed, the brain is really, really busy. There's all this internal processing going on really, really fast, and you're going to see this shortly. Hold on, okay? And then when the eyes are open, sometimes the lights go. Have you heard that saying, the lights are on but nobody's home? Sometimes we see that. We see brain fog. You've probably heard that term, especially even COVID brain fog. So that's just another application for brain mapping. You can actually map that out and see it, and you can treat it with photobiomodulation. So back to what we were talking about. So the data on the left here is with eyes closed. Data on the right, sorry, I didn't label that. Data on the right is with eyes open. Now what we're seeing here is the breakdown of the brainwave speeds from slow to fast, and delta being slow, that's the dominant frequency when people are asleep. It's also in very short bursts of delta and theta. That's where your brain goes to those frequencies, just short bursts, like a third to a half of a second, to retrieve memories. It's like your mental filing cabinet. Theta is the dominant frequency when people are in a state of meditation or prayer. Also, it's the dominant frequency. It's that hypnagogic state before you fall asleep, that kind of drool stage. Alpha, there's two speeds of alpha. Basically, alpha is the bandwidth between 8 to 12 cycles per second. That's the dominant frequency when the brain is on idle. Similar to when your car is in park, but the engine's running, it's idling. And think about, you've got timing, okay? You've got timing. If your car, for instance, my car has 6 cylinders. All 6 cylinders need to be timing. The timing's got to be just right. The idle's got to be just right. The engine will still work, but it may not work efficiently if all the cylinders are not on the same timing. We refer to that as the alpha peak frequency. We're going to come back to that. And also the idle frequency. If it's idling slower in maybe the 8 to 9 hertz range versus faster in the 12 hertz range, that's going to affect your performance too. Think about when your car is idling too slow or too fast. When it's going idling too slow, it might kind of sputter or stall out. And if it's idling too fast, it might result in the wheels spinning or press the gas and it's going to have explosive action. Now, this is a case of a player who had some explosive reactions. And furthermore, temporal lobe transient activity, basically these spiky alpha brain waves in his posterior temporal lobes that didn't belong there, that resulted in some mood and some affect and some issues and behaviors that were not appropriate, and he didn't even have any recollection of them, because that's also where memory happens. So it explains. Did you ever have a client or somebody that you know, and you say you ask them or ask yourself, why did he do that? Or I don't want to pick on men, but why did that person do that? What the heck? Well, it has to do with how their brain is functioning. So alpha, once again, is the brainwave speed when they're on idle. Beta, that's the brain on task. All of us, ideally, we're in beta right now. This is the brain on task, processing cognitively. It's the brain in action. Focus happens here. Beta 2, beta 3, this is fight or flight. This is where stress lives. This is the speed of stress. We need all of these brain states at different times for different tasks at hand, just like we have different speeds, gears of a car. We use them different speeds and different gears for different types of terrain. Same with the brain. And this data here is z-scored data. If you're familiar with the bell curve, whereby green, light, sort of this turquoise color, yellow, and orange. This is within normal limits. Now, normal is just a setting on your dryer. We use it as a reference point, and we look at outliers, and then we start asking questions, just like when you have lab work done. You go get blood work done, you get the report back, and when things are out of range, that's when the doctor starts doing further investigation and asking questions. Same with the brainwave speeds in the brain maps. So then gamma is ultra fast. That's like that aha moment, really fast processing. And once again, where there are certain ranges that we expect to see. And the really unique thing about the iMediSync database is that it has a database for males and females. Okay, according to research, male and female brains, they do have differences, and we do have different patterns and different values that we expect to see. So this is the only database out of many, but this is the only database that actually puts males into a male database, females into a female database. You're really doing people a disservice if you don't do it that way. Now, this eyes open data, and we're seeing a difference here. So basically, what we're looking at here in the topographical data, it's going to get even, I'm going to show you this in 3D as well. So with each one of these circles, the front, this is the top here, you see the little nose. The bottom of the circle is the back of the head. And if you see my cursor, this is the left, the ears, this is the left side of the brain, this is the right side of the brain. So this is kind of flipped from your standard medical imaging. For those of you who are in the medical background in radiology, we would be looking at the right on the left side and the left on the right side. So FYI, just keep in mind, this is the left side, this is the right side in EEG world. So what we're seeing here is more delta or slow brainwave activity in the left posterior quadrant, even more in the theta, in the whole back of the brain. And I want to point out here the imbalance. See how there's more of this slower activity in the slow alpha band and the theta band range. So this goes from 4 to 7. This is from 8 to 10 cycles per second. And we're seeing here, it's not exponentially so, but there is an asymmetry or imbalance between the left and the right side of the brain. So this individual has more slow activity in the left front part. This is basically the left dorsolateral prefrontal cortex. This is the part of the brain that has projections from the nucleus accumbens center, which is the reward center. Okay, so basically this is where pleasure and happy happens. This is according to research from Davidson's lab. The left frontal cortex is in charge of positive emotions, approach behavior, willingness to try new things. I like that, I resonate with that. The right side is associated with negative emotions, avoidant behavior, emotional reactivity. And so what we're seeing here, this is analogous to trying to run a 5K or a marathon with a sprained ankle. He's got more slow activity on the left front side of the brain. We're seeing that with eyes open and eyes closed. There's an imbalance. So more slow EEG, slower, inefficient EEG would result in him having a harder time observing, processing, experiencing positive emotions. His right side is working more efficiently. Is it going too fast? I would say the whole front of the brain is going a little bit. This is where we would call this too much of a good thing. Furthermore, even in fight or flight, there's too much fast stuff going on in his frontal cortex. It results in him processing too fast. Basically, he's processing so fast that he's not taking the time to really make good decisions, which would result in impulsivity. Definitely had clinical correlations. And here's another thing I want to point out. Look at this excess of slow alpha. Now, we expect to see a dominant alpha frequency at about 10 hertz. I'm going to show you what it looks like in a spectral diagram. But basically, we expect the average dominant speed to be around 10 hertz. But he's got more of the slower stuff and even more, once again, on the left side with his eyes open. Look at the difference. This is a brain. Ideally, you want to be focusing, you want to be processing up to speed, especially with your eyes open. But look at the prevalence of slow alpha with eyes open. So this is a guy who's having a hard time. Basically, he's got one foot on the brakes and one foot on the gas pedal. But where's the cruise control? I mean, he does have enough beta, but basically what happens when you got one foot on the gas and one foot on the brakes? You're basically not going anywhere. Next slide. Now this is a spectral display of what we're seeing. Once again, front, back, left, and right. Each one of these graphs represents the data underneath each one of those electrodes. And see this spectra here. On the vertical axis, we have power. And on the horizontal axis, it's hard to see these little numbers, but on the horizontal axis, we have frequency. You can see how there's this peak. This is the dominant rhythm. We expect to see these peaks, and it's a little bit less than 10 cycles per second. And we're going to see that in a minute. So, and we do expect to see more alpha in the back of the head, and but we don't expect to see so much alpha frontally, and especially more on this left side. And we don't expect to see so much in the temporal lobes. And if you go back and remember, what happens in the temporal lobes? Memory, moods, auditory processing. So this is a guy, you can be talking to him, but with all that fast processing, he's having a hard time paying attention. And furthermore, he's not processing sound so well. Oftentimes we'll also, this is a pattern that we see with migraines and ringing in the ears. Tinnitus is just a faulty processing or perception of sound in the brain. So once again, and then this is Z-score data where you see this red here. That tells us there's more than we expect to see in that frequency. So this is what it looks like when you compare everything by spectra, not just the. So I spend a lot of time on this screen here so that I can get an idea of the frequency and the distribution. Now, what's really neat about this software is when you go back, this really helps me to target frequencies. And for those of you who are involved in research, you know, it's one thing to have these beautiful maps with all the colors and it makes it easier to describe to people. But when we're doing research, we really want to get numerical data. So I can drag my cursor along anywhere on each one of those graphs at every site, and I can get numbers. If you look here on the right side of the screen, we can actually see the numbers, the frequency where I place my cursor, and or the speed of the brain waves, and how much power. And here we're seeing numerically, this is this asymmetry here in the frontal lobes. This is right here, F7 and F8, okay? And we're seeing quite a significant more slow alpha activity on the left side than the right side. So we're actually able to map it out, and we can compare pre and post and look at progress as well. And that was with eyes closed, and here's with eyes open. We're seeing the same thing. We're seeing these asymmetries. And now here's the 3D, and I'm going to take the last few minutes. I'm going to show you how I derived all of this data. We'll actually go into his file, and I'll show you how I was able to procure these images and put them on my slides. So basically, this is a 3D rendition, okay? The software takes all of those squiggly lines, all of that data, and takes it and puts it into a 3D image so that we can get a really good solid look at it. This is, once again, this is the left side, this is the right side, this is the front, the back, and this in here is the deep limbic lobes. This is where emotions live, in the back part, the posterior cingulate gyrus. Okay, this is where your head focus of attention happens. And look at this piece. Basically, we're seeing way more. So it was more like it was about in the caudal anterior cingulate. So almost 3 standard deviations. So this is an outlier. He's got more, and this is windowed at beta. So basically, he's in his head focus. This is why the guy isn't sleeping. He's got this hyperactivity. His brain is on task in the back of the head. Furthermore, less so in the frontal cortex. Now, it's not like we want him to be thinking and reasoning and stuff like that. He's reasoning in his deep limbic lobes, internally, with his eyes closed. Okay, this is eyes closed data. And furthermore, the frontal cortex doesn't have the inhibitory control. Remember, anterior cingulate gyrus doesn't have the inhibitory control over these internal emotions. This is why this guy, he can't let it go, and he can't turn off his brain and fall asleep at night. It makes sense. Now, also, for those of you MDs, and you do not have to speak up, but tell me, what sleeping pill, what medication, and it doesn't matter how much weed he smokes. That's why he had too much alpha activity going on, by the way. Cannabis causes a prevalence of 10 hertz, which is a nice place to be, but you don't want your whole brain to be there. Once again, tell me what sleeping pill is going to quiet down this part and tune up this part so it has inhibitory control. Doesn't happen. But with photobiomodulation and the iMediSync wave helmet, we can actually target where we want the alpha to go here, where we want the beta to go here. And once again, treat accordingly. Affordable, portable, can be used every day, even at home. So that's the neurophysiological underpinning of his hyperemotion, his explosive, impulsive behavior. Now, this is, once again, high beta in the limbic lobes. So this is even faster. This is the fight or flight, and it's even moving more anterior. So this would keep anybody up at night if you're stuck in this hyper emotional state. Now here's with eyes open. We've got excess high beta in the anterior cingulate gyrus. It's basically revved up. It's like going too much of a good thing. This positively correlates with overthinking, difficulty shifting gears, hypersensitive error detection, and difficulty cooperating. Had everything to do. And people, nobody understood him. The guy was arrested 3 times, tased him. They had to sedate him. I mean, and we're talking about football players here, big, giant, over 300-pound guys who are having explosive, over-emotional reactivity, can't get out of their own way, stuck in their head, making impulsive, bad decisions, and they can't help it, okay? And they're big, giant guys, and when you got these big, over 300-pound guys, it scares people. And I told him, I'm like, dude, I could behave that way. I'm not going to scare people. I don't even weigh 100 pounds. I'm like a little 5-foot tall person. I don't intimidate people. But these big 300-pound guys, they scare people, and they overreact. People, they call them, this happened. I'm the one who got these guys who had been in trouble. They've been hospitalized. Literally, they've been sedated. Some of them, I've got guys, this one included, sedated to the point where they actually stopped breathing, and he couldn't help it. Okay, I put him, and then the medications, we can use the quantitative EEG and look at the brain waves, and we can actually even use that information, not just to target photobiomodulation protocols, but also to figure out how that brain's going to respond, if it's going to respond to different medications, so that we can get them treated appropriately and help them. I'm going to stop. Wait. There. Now I'm going to minimize this, and I'm going to open up and I want to show you where I got that data here. So this is actually, I just opened up in FYI, this software, unlike some others, it's in the cloud. So I can access this from any computer just by logging into my account, go to anybody's file, download those images were from downloadable reports. I just click here, I can download, export it into a PDF, send it wherever it needs to go. This is what the raw data looks like. This is how we choose. We can actually edit it, choose the components we expect to see. This is where I got those other images. This is the data that you were just looking at. This is his folder, okay? This is a real case, didn't make it up, okay? And this is where we were looking, and FYI, here's where I clicked, compare, and this is where we can actually see there's that asymmetry right there. So once again, this right here is the neuromarker of depression. There's a whole book written by Dr. Yuri Kropotov, Neuromarkers of Psychiatry, Functional Neuromarkers of Psychiatry. I encourage you, if you have any questions, I'll share my contact information, but this is where we get some of this stuff from, always looking things up in the literature. And once again, here's that, you can see it a lot better when I open up this image. And here is that excess alpha in the posterior temporal lobe. This is also a marker for PTSD. We see excess idling here. This is where people just shut down to the world and to other people, and they go in. Once again, we saw that high beta in his posterior cingulate gyrus. And that's exactly what's happening in his brain. This is his alpha dominant frequency here, and 9.5 hertz. So he's within the normal range, but we do not expect to see this other peak right here. He's got this faster peak right here. This is where his brain, the timing's just a little bit off. We don't expect to see this in the beta band range. Theta to beta ratio. This is something that we look at. How much slow waves compared to how much fast waves. He's got about twice as much, a little bit more than we expect to see, slow compared to fast brain waves in this right posterior temporal region, and also here on the left side. Once again, ask yourself what happens in the temporal lobes. This guy's got excess idling in the posterior temporal lobes, and it's affecting his function. Now, this is where the real magic happens. This is where we got those 3D images. And I'll just show you real quick. We can just use this to navigate. Here we go. So here's his brain activity. This is all data from the raw EEG. And we're going to go back and we're going to look here. So this is how I derived that. So I go through this. I spend quite a bit of time navigating my way through. And we can look at one side versus the other. We can navigate our way through different band ranges. The dominant, the most deviant outliers are going to show up here. We can look at the left side. We can look at the right side. So I just wanted to show you guys how we come up with this information, where it comes from, and once again, how we use it to understand our people. We can work with therapists, we can work with doctors, psychiatrists. I'm going to stop sharing now. And I'm going to invite you guys, if you want to unmute people for a couple minutes, if there's any questions, I will do my best to answer them.
Thank you so much, Becky. That was wonderful, very informative.
You're welcome. Oh, contact information. I didn't do that.
Yeah, please put that in the chat.
Oh, okay, I can do that. Here. Okay, I'll put it in the chat. Cancel. Okay, go ahead.
So we have a question in the chat about any success treating addiction, stopping the craving for drug or food or whatever the substance is.
Absolutely, absolutely. 6 years of clinical experience, okay? So There are, and if you're interested, I can share a paper written by Jay Gunkelman and Joy Lund. There are neurophysiological underpinnings of addiction. There are neuromarkers of addiction. We were able to map it out. Once again, 6 years of success. In fact, our lab was featured on Fox 11 LA News due to our successful, our really high success rate working with addictions. And once again, the center I worked at was for TBI and addictions recovery. Most of this comorbid, okay, because our guys, they were struggling with trying to quiet that posterior high beta, trying to wake up. So we had polysubstance abuse and basically guys self-medicating and addictive behavior. And then furthermore, the painkillers. So absolutely. And once again, when we can look at why that person, what's going on in their brain, it helps us to target the treatment to help increase the success rate or efficacy of the addictions treatment. I saw another
Dr.
question.
Bruno has a question.
Yeah, first of all, thank you for your presentation,
You're welcome.
Rebecca. Thank you, Rebecca's, by the way.
Rebecca squared.
Yeah, exactly. One thing that actually is pretty clear for me as a Brazilian, I'm not a big fan of NFL, but from time to time watching some games, is actually NFL has improved the policies over the last years since the release of the movie Concussion from Will Smith, right? And how do you see nowadays those policies? And number one, and number two, do you think that there are still room for improvement regarding these policies from NFL? I mean, regarding concussion, of course.
Well, I'm going to plead the fifth on some of that question because I don't want to get myself in trouble. I'm not a fan, or I mean, it just makes me cringe when I watch football. And I mean, okay, so here, let me just answer the question like this. You've got a helmet on the head, and I wasn't a football player. I was emphasis on was an equestrian. Okay, I fell on my head many times with and without the helmet. My helmet actually has a hole in it now. The last fall took me out, and there's brainwaves that are so here's the thing. The helmet protects the outside of the head. It can protect it, but the brain is still going to be moving. You've got two guys colliding, but they're big and they're fast, way faster than you and I, and they're colliding over 300 pounds of them. Tell me, really, the brain is still going to be moving back and forth within the skull. Okay, you can't change that.
Even though the helmets have improved.
They have improved helmets, but
yeah,
it's still not going to fix the force of the brain moving within the skull.
Yeah.
So
on the same page. Actually, if you don't mind, I have some comments, because of course we have Brazilians here, and as Brazil, of course, we are way more fan of soccer and MMA, which is a very common sport here in Brazil as well. And one thing that's pretty clear for me regarding the utility and of iMediSync is because nowadays we've been watching. I can say for myself as a sport practitioner, and there's a huge need and search for performance. I'm saying not for professionals, for amateurs like me. And one thing that actually is pretty clear for me regarding iMediSync, if you want to apply it for soccer, for example, you can use it beforehand, before actually the season itself starts, and can give you many ways by which you can compare with afterwards. I mean, in the beginning of the season, at the end, regarding, for example, concussion, stress, anxiety, and not only that, but we have many papers out there that actually they have been pointing out that actually you can see performance by, for example, measuring high frequency bands. As you know, it's really interesting for us because people are seeking performance, and you can use a 10 minutes tool that actually can measure everything with many variables, and you can send reports for coach, players, and families, and all those people. And for me, it's really appealing having a tool like iMediSync, because we have many variables in your hands nowadays compared to, for example, 2-3 years ago. That's one comment number one. Number two is actually there are some, I would say, subjective complainings in some patients, like, for example, insomnia. How can you imagine insomnia, stress, anxiety? Sometimes it's difficult, you know. And having a system like iMediSync that can give you those information, I think is essential for us. Another thing for as a neurosurgeon, Rebecca, is for me, for all that stuff that actually iMediSync can give us, is S-Loretta. For those that actually don't know, S-Loretta is low resolution, which is not a low resolution, as you said. It's 5 millimeters resolution. It's not so bad. And being able to watch, actually to see brain functioning with imaging like S-Loretta is awesome, because it's another way of watching your brain without being exposed to X-rays like CAT scan or a time-demanding exam like MRIs. So there are many applicabilities, I think, in iMediSync. For me, it's awesome, really exciting to watch your presentation with those data.
So I'll second that. Two comments I have on that, Dr. Bruno, is I've started out in radiology, and I was fascinated when I found out about EEG, quantitative EEG, and neurofeedback. I really resonated with it, because I saw exactly what I would expect to see on a functional MRI image in the quantitative EEG. And that's when I knew it was real. And I'm like, oh my gosh, but not just imaging it, but now, rather than just being stuck in my ivory tower behind the scanner, is a great job, but I saw so much sickness and disease, it broke my heart. This allowed me to be part of the process of helping people get them where they want to go. Now let's circle back to the peak performance. Yeah, there are different, because I worked with Sue Wilson. She got me started, helped me set up that psychophysiology lab at the Hall of Fame Academy. And what we were doing is, there are different states with the athlete, be it from amateur all the way to professional. There are different states that we want to be in. There's the get ready focus, there's the flow, there's the explosive action that you want for a time, and then there's the let it go, and there's the fall asleep at night. There's different brainwave states, and the key is being able to shift gears. Once again, you've got different states for different, and you want to be able to shift gears, not just shift gears, but be aware and be in control. Did anybody ever say, just control yourself? Okay, it's all that, being able to control and shift gears, boom, on a moment's notice, and having things happen in patterns, like muscle memory with sport. Having the brain be able to shift gears, go from task to idle, and not just athletes, but they've worked with military, peak performance, Top Gun, and even pilots as well.
Nice, perfect. Thank you. For Brazilians, actually, that they're afraid of asking English, if you guys wanna ask or write something in the chat em português, I can translate. Okay? Para os brasileiros que quiserem perguntar alguma coisa, podem escrever no chat que a gente traduz, tá bom?
And I cannot find my chat button anywhere, so I put my slide up real quick with my contact information, so Rebecca can share. Can you put it in the chat?
Yes, I put your email in the chat, and we do have a question from Camilla Is there any data regarding youth sports, especially in football, and the effects of concussion in the long term?
We've got some people working on that. I'm not at liberty to discuss it, but there are some people working on that. Stay tuned. Stay tuned. Something's going to be coming down the pipes.
But in general, the younger brains have a harder time protecting themselves against concussion.
Absolutely.
And yeah, so.
And furthermore, they're still developing.
Right.
They're still developing.
There are some papers actually there out there showing that if you start your journey in sports before 12 years old, it's even worse.
Yeah.
And
12.
most of them do,
Mhm.
especially nowadays, and even very competitive. So yeah, these are some things to think about. But two things I really want to emphasize is getting a baseline, the importance of getting a baseline brain map pre-season. On one hand, people may want to put their head in the sand and not want to know. But on the other hand, man, when something happens, I had a client just last week. Somebody had a seizure. It was a 25-year-old young man, and he wasn't an athlete, but he had a seizure. First time ever at the age of 25. And we saw epileptiform activity, just even he wasn't seizing or anything, but I saw epileptiform activity in his eyes open and his eyes closed files. And typically we would only see that when they're not actively seen. We would see these transients only in transitional, typically more often in transitional states of drowsiness. But we saw it when he was awake, wide open. Epileptiform activity. The guy was a slow temporal lobe transients, and combined with cortical hyperexcitability, excessive beta spindling. Nobody, if you hadn't done an EEG, nobody would have ever identified that. And furthermore, if we only had a baseline, we don't know if that's been happening for a long time. We know it's still happening. So if we only had a baseline. And so the importance of the baseline, I think it can't be overemphasized.
There's another question from Jamie. He's interested in knowing the caseload for private concussion clinics that are treating high schoolers. Do you see a lot of high schoolers coming for help with the concussion?
Not a lot. Well, in my where I was focused on concussion, it was we didn't take children, only 18 and above. But I did, in private practice, I did have a group of high school football players. It was one mom and brought in her son and a couple of other friends. And I can tell you that those cases, I don't have time, but if I could show you this kid, high school, he was a junior at the time. It was a summer before their senior year, had these kids in, and their brain waves looked every bit as bad as those professional football players that came in. And these were 17-year-olds. One of them had been having seizure. His mother brought him in. He was having all kinds of symptoms. His mother finally brought him in. He had a seizure while he was driving her and almost took the car over a cliff. That's what it took to get her attention. And his body was having tremors and focus issues. And so I don't see as many as I would like. I can only speak for myself. I wasn't quite in that venue, but it's really important to address these things.
Okay, and there's two more questions. One is, can you talk about how PBM is applied and address specific areas with specific frequencies?
Oh, that's a fabulous question, and I'm sorry I didn't touch on that. So in the case of that case that I just showed you, what we would want to do is set the cap at 10 hertz in the posterior, right and left side in the posterior. Even though he still had enough, the alpha was a little bit on the slow side, more so on the right side. But basically, I tell them when they're having the cravings for cannabis, back to the addictions thing, let's give you the 10 hertz where you need it. Let's spare. We do not want the frontal cortex in 10 hertz. Okay, you don't want your frontal cortex idling. That's going to result in bad decisions, being checked out. But specifically apply it, the alpha, back here where you need it to calm down the cravings. It's basically, I tell them, here, this is what I do this is my weed or my alcohol. Basically, that's what I tell them. Like, oh, okay, they could get that. And then the beta, he didn't need the beta in the back, right? Okay, so if you take something for ADHD or ADD, for instance, some sort of a stimulant medication, it's going to stimulate the whole brain. Well, we don't want to stimulate the part that's already got too much too fast. We just want to apply the beta to the front, and maybe even a faster beta to the left front to get that part of the brain woke up so that we can start experience. This is the dopamine, okay? So basically the dopamine, the alcohol, the weed. So we use the frequencies, apply them site specifically and frequency specific to the state that we want to achieve. Very good question. Thank you.
Yes, and then Mel Tucker is asking, do you know of any sports that are using qEEG as baseline data? And if not, why are not more sports using this?
I do not know of a team. I'm trying to create something. I'm in the process of creating a baseline EEG service where we're going to travel and offer, just collect the data, just make it affordable, collect the data, don't even have to do anything, but just a baseline recording and provide it for that parent, keep it in a data bank for future use. So no, I don't know of anybody actually doing that. Like I said, I'm working with a business partner, creating a service whereby we can travel and go do that for people and offer it in an affordable fashion, make it affordable and functional and accessible to more people. And what was the second part of that question?
Why do you think more people aren't using this in sports?
Oh, okay. So I can tell you, this has been my experience within the NFL, and I would just say it is there's some people in even within high school and college, sometimes people don't want to know. Maybe the athlete doesn't want to know, because then if we knew, then they may be excluded from the game. They don't want to stop playing. And I had to just keep my mouth shut when I was at that academy, because I saw EEG that they didn't have the down the road over time. It's like, oh my goodness, dude, being cut from that team is probably the best thing that ever happened. It may not seem like it right now, but the last thing you need is to have another head injury. And that's why I stopped riding horses. Just can't do it anymore. It's not wise. And especially with multiple TBIs. So sometimes people just don't want to know. It's a denial thing. And sometimes it's about liability. So yeah, it's great if the baseline shows up and everything's all good, everything's within normal limits. But now, who's going to be liable? So say that kid has a concussion. Well, as the player, if I really am interested in my brain, maybe the person's just interested in having that NFL career, and they don't care what their brain looks like. They just want to play. Go, go, go. I'm going to push through it. I'm going to try. Oh, holy moly. If they only knew what happens at the end of that pipeline. But then who's going to be liable? Is the school? It's so say there is some finding in the follow-up qEEG after the concussion. It doesn't, no matter how severe the concussion is, say we find something. Well, now what are they going to do with that information? Well, I'll tell you what, I have 3 children. They're all grown now, but as a parent, man, I would want to know. I also had a kid, one of those kids who came to me that summer back in 2020. Okay, we worked through COVID. And the kid's dad wanted him to play to get that scholarship. The kid did not want to play, but the parents wanted him to play. So it really just depends on the intentions.
Becky, I wanted to interject with elaborating on that question about why are more sports not implementing qEEGs. I know for iMediSync, that's one of our goals, is we want to care about brain health, and not just people that might be suffering from depression or anxiety, but also in the sports medicine. And that's one thing that's really nice about iMediSync, is because we're dry and wireless, we can be on the sidelines. Most devices require a computer and a plug-in and wires, and it takes a little bit longer to collect the data. And so that is one thing that we're hoping we can move forward making it more convenient and easy to receive those assessments. And then Mel also added to his question about what kind of sports training would the staff need to implement that system of getting those baselines?
So that's another thing I'm working on with my business partner is training techs to, you know, I'm certified. There's some of you here in the audience are certified in quantitative EEG, but coming up with a program to train techs how to collect the EEG and do a good job. It's not just about putting the helmet on. You've got to get it just right, know what you're looking at. And so I'm in the process right now of creating a training program so that people who have this helmet, and I woke up, Rebecca, I will share with you, you and I, we're on the same wavelength. So is that not just the same name, but but I woke up with a vision this morning is that every team, not just football, but teams that involve direct contact, you know, potential of head injury, that every team have a helmet, and that it would be in every locker room, and every trainer would have a helmet. And when the helmet is sold, that person is adequately trained and to know what to look for, or even perhaps even offer a service. I would be more than this is, I do concierge work and remote work. This makes my heart sing, so I can reach other people and I don't get bored sitting in my office all day. So being able to even connect with somebody such as myself or Sherry offline or online. So you put, I have people that I work with remotely and they put on the equipment and then I'm on the other side and checking and double checking. Okay, we're good. Everything's hooked up. Okay, it's a go. Now, boom, download. I'm going to look at that data for you.
Yeah, and I will say iMediSync takes pride in making sure that everyone who has a device is well trained and feels confident in collecting the data. So I know we're getting short on time here. Are there any other last minute questions or any questions from our friends in Brazil? All right. Well, thank you so much for joining us and for your efforts in your own individual ways to helping improve brain health and assisting with our sports medicine. Thank you, Jamie. We appreciate it. They're complimenting you, Rebecca, saying a wonderful webinar. You've done a great job. We got some.
Thank you.
Thank you very much.
Thank you very much.
And feel free to reach out if you have any other questions.
Thank you so much. I enjoyed it a lot.
Thank you.
Thank you.
Bye, everybody.
Bye.
Thank you very much.
Okay, we do. Rebecca, are you still on? I don't see you. All right. I'm going to go ahead and close out. Thank you, everyone, for being here. And we look forward to March 7th, HRV and EEG. Where's the party? All right. Bye.